Good morning, my prof. Today I will present you my work under title Realizing a 7-leg inverter controlled by a new FTC to drive induction motors in the normal faulty cases with the same performance. I will beginning this work by introduction, then control dual induction motors by independent technique and present experimental results. After that, present the many problem in the inverter. It is the fault. After that, we can propose solution. It is a 7-leg inverter controlled by new control FTC with experimental results. And finally, we can conclude many advantages in this work. Recently, industrial applications require many motors and multi-converters such as electric traction, textile and paper industries, autonomous mobile robotics, and naval propulsion. These applications often require a number of electric vehicle speed drive, that is mean two or more electric converter. We can remark the number of electronic devices here is high, and the global of these systems are very complex. The weight and the size are high. The cost is high. So the problem is posed here: how to realize a system of multimotor with a single converter. This converter, it is 5-leg inverter, can be supplying two motors. It is controlled by a fork. This picture presents the control a fork for each motor. It is the same control 2-3-leg inverter. In this paper, uses independent technique as shown in this figure, and these equations to explain the principle of the technique. By FOC we have 3 reference tension for each motor. After that, minimize one tension from other, and finally we have tension equals 0 for two motors. This is for common leg. We can present now experimental results. This present two reference different speed and the good response speed of induction motors. Each one follows a reference speed without influence one to other. And this figure shows the reference new European driving cycles is taken as an example one of the references in order to test the control FTC of the 7-leg inverter of its effectiveness in the case of the fault. And this figure presents many different faults can be occurred. After studying, it is found more than 38% of inverter faults are due to faults in power electronic devices. These faults may stop operation completely or degrade performance. The FLI cannot assure continuity the operation when the fault occurs. So we present the solution. It is 7-leg inverter. It has 5 legs activate when the case the normal, and 2 legs additional connected by another machines are activate when the problem is occurred. This inverter controlled by new technique, it is FTC. The principle this technique, it is monotometric force pre-fault equals multimotor's force post-fault. We propose now as example an upper IGBT of the leg B1 is faulty. These factors present two cases, normal and the fault. The normal case presented by black vector IBC, and the fault case presented by red vectors that are rest AC to currents. After eliminate the leg faulty B, and that are augmented by root 3 and achieved by an angle. These equations present post-fault current. At this work, fault is proposed in such a way to apply directly FTC is the principal objective in this paper. This figure presents two states, normal, one green single take 1, and fault case, one green single equals 0. We can see the positive half of the current B is set to 0 due open circuit the IGBT upper in the leg B. This fault leads to degraded performance. For avoid this problem, must be isolated this leg that has a faulty by opening the switch disconnected. As shown in the figure right, speed the induction motor's one in the moment operates and stops in other. This shows the currents induction motors one in the case normal A1, B1 and C1, and the second case when the fault is occurred in the leg B1, it is replaced current B1 by N1 and raising the currents A1 C1 by root 3 for to keep monotometric force constant as like the case of the pre-fault. This picture for speeds of dual induction motors are fed by 7-leg inverter. It is remarked to have slightly affected in speed induction motors 1 compared to a reference due the fault is occurred. After that is applied to FTC allows reflow induction motor 1 speed to reference as in the case the pre-fault. We can conclude now this work presents a new control FTC with an independent strategy to feed to induction motors by a 5-leg inverter with the 2 legs activate when a fault occurs. FLI allows having many advantages as a size, weight and consequently reduce the cost. An independent technique shows in its efficiency in controlling 2 machines without one machine affecting the other. The new structure 7-leg inverter with FTC give us the same performance machines as in the pre-fault. Thank you for your attention.